at rest. And we have seen that due to the charge at rest, electric field, we have studied electric field, electric potential, okay?
Mm.
Electrical energy, electric force we have seen.
Yeah.
Now we want that what will happen when the charge starts the motion. Charge start the motion. And now what is motion? Motion is changing the position with respect to time. Motion is the changing the position with respect to time.
Time.
And I will explain each and everything. Well,
Yes.
I'm just giving you the idea. Basically, we have to study in this chapter about the current. Current, electricity, very easy, I will say easy chapter. So we know one thing we should know. We know the mass. Mass is the property, like mass is a property of matter. Similarly, you can say charge is something. Charge is something like mass, which is also the property. Okay.
Yeah.
And there are two types of charges: negative and positive charges.
Yeah.
So when all the things are happening due to the charge. Okay.
Yes.
So when the charge at rest, when the charge at rest, and we have studied the electrostatics unit, electrostatics, and in that chapter you have seen that there was no current. And
Okay.
why there was no current, I am just telling. Current will be only generated when charge is in motion.
Okay.
Now this is charge. Now this charge is in motion. This charge is in motion, and due to the motion of this charge, the current is generated. And
Yes.
motion. About the motion in the 11th class, if you have forgotten, then no problem. I am telling. There are two types of motion: uniform motion and accelerated motion. In the
Yes.
uniform motion, the velocity is constant. The velocity is motion. You can do the motion. You can do the motion like if you are moving with a constant velocity. Either you will move with some variable velocity, means your velocity is changing with time, with 5 meter per second in east. After that, 10 meter per second in east.
Yeah.
Then motion, I can say, can be performed with, this is the motion of charge. The motion of charge can be with variable velocity, or it can be with constant velocity. It can be with constant velocity. Okay. When the charge is moving with constant velocity, means I am representing acceleration with A. Acceleration is equal to 0. We know that acceleration is change in velocity divided by change in time, delta t.
Yes.
Okay. Or in the instantaneous form, you can write A is equal to dv by dt. That's not a problem. Means you can say change in velocity is 0. This term is 0, means acceleration is 0. And here the acceleration is not 0, because this change in velocity is not 0. Acceleration is not 0 because this change in velocity is not 0.
Yes.
So in this chapter, in this current electricity, we will mostly study about the charge moving with constant velocity. And this motion is also known as this motion. When the charge moves with variable velocity, means the velocity is changing. So this motion of charge will be known as accelerated motion. And this motion of charge is known as uniform motion. Uniform motion. This is just a basic idea about the chapter. And now, from here we will study the current electricity. This chapter is all about this. All about this. Current electricity. And when the charge will perform the variable moves with variable velocity, we will see this in electromagnetism. Electromagnetism. Now you can see the sequence. First chapter is electrostatics. Charge was at rest. Second chapter is current electricity. Charge is moving with constant velocity. Third unit you will study the electromagnetism. In that you will see the acceleration of charge, mean the change in velocity of charge. Okay.
Yes.
So the first term is electric current. First term is electric current here. Electric current is generated. Electric current is generated when the charge performs the motion, whether it is accelerated motion or it is uniform motion.
Okay.
So electric current, the definition of electric current is, you can say, rate of flow of charge. Rate of flow of charge. Rate, we have seen rate in many times we have seen, right? Like I am giving just the example. Rate of change of momentum. Rate of change of momentum. I am talking about the linear momentum. Rate of change of velocity. Okay. Rate of change of displacement. So these are the terms we have seen. Rate of change of linear momentum is equal to the force applied. Rate of change of velocity is equal to the acceleration. Rate of change of displacement is equal to velocity. So we have seen these kinds of things. Means rate means, what is the meaning of rate? Rate is something is changing with respect to time. Something is changing with respect to time. Rate of change of momentum means, you can say, dp by dt. P is the momentum here. Acceleration is dv by dt, and here ds by dt. So I am just giving the brief idea about this, and no need to write this.
Yes.
So means rate of flow of charge. Current is rate of flow of charge. And where is it? Okay. So rate of flow of charge. And I will represent this electric current with capital I. Capital I will represent the electric current. So for the electric current, I can write I is equal to charge flown, the amount of charge flown, and you can say the amount in the amount of time, means time. So current is charge upon time. Current is charge upon time. Okay. So suppose this is the conductor here. You can see this is the here. This is the wire, na? This is
Yes.
the wire, and in this wire the current is flowing right now, and the current is flowing. This is the conductor. This is the conductors, and conductors allow current to flow.
Yes.
We will study this also in this chapter. So, okay. So I am taking a conductor, and I want that you should understand the meaning of what the current is. This is a cylindrical conductor. This is a cylindrical conductor. This is a cylindrical conductor, and this is the cross section area of the conductor. Cross section area. And the cross section area is same throughout the length of this. So here also the cross section area is same. So, and you are here right now, and you are what you are staring means you can say you are looking here. Your eyes are here. Okay, your eyes are here, and I am saying from this cross section area, the amount of charge flowing is delta q. This delta q is the amount of charge flowing, and suppose you are watching this cross section area for the time delta t. Delta t is the time.
Yes.
I am just giving you the understanding. I have written the definition, but you should know what is the current. So suppose
Yes.
you are watching this cross section area for the time delta t, and you have noticed that, delta q charge is flowing in delta t time. Delta q charge is flowing through this cross section. Remember, through this cross section in delta t time, and this is known as average current. Like average velocity, we have average current. Average current. Average, we take the average when there is a fixed amount of time, like for 2 seconds, for 5 seconds. Suppose you are here for the 5 seconds. So you will measure the value of current, that will be the average current. That will be the average current. So I will represent average current with I, capital I into AV in this short form. So average current is this, and now I am saying that you calculate the current if we want the current at an instant of time. Like this is the wire, and you said to me, tell me the current right now. So means you are saying this to me instantly, at an instant of time. At an instant of time, then in that case you will use this delta q will change by dq by dt.
DT.
And we have done this also. You can see here, acceleration is when we want average acceleration, then change in velocity will change in time, and we want when we want instantaneous, when at an instant of time. So means you can say at an instant of time means this delta t is very small. That delta t is tending to zero. Delta d is not equal to zero, but you can say it is approaching to zero. It is approximately equal to zero. In that small amount of time, you will represent that small amount of time with dt, and charge flow in that small amount of time will also be very small. So that's why I have written this. So in the same way, we have done all these things. This is average acceleration and this is instantaneous acceleration dv by dt. So in the same way, I am writing the instantaneous current. Instantaneous current. So instantaneous current, the formula is dq by dt, and I will represent instantaneous current as INS. This is instantaneous. Instantaneous. So average current and instantaneous. Remember these things.
Yes, sir.
This is average current. This is instantaneous. For measuring the instantaneous current, this delta t is very small. Delta t is very small. So for the small delta t, I have written dt. I have written dt. So now the unit of force is Newton. Unit of
Yes.
force is Newton. Like current also have the unit. So now unit of current. I am discussing unit of current.
Ampere.
Yeah, ampere. You are right. So unit of current, and how can we calculate the unit of current? Current is charge divided by time. Charge divided by time. So charge, the unit of charge is coulomb,
Yeah.
and unit of time, as a unit of time, I can write in second. So coulomb per second is a quantity named as ampere, and we will represent this ampere with a small a. Sorry, capital A. So unit of current is ampere, SI unit. This is SI unit. SI unit. Okay. So this. Now we know that there are two types of quantities. We have studied in 11th class. If you know, then it is good. If you don't know, then I am telling you. There are two types of quantities: scalar quantities and vector quantities.
Yeah.
Scalar quantity, yeah.
Scalar quantity has contains only direction. Vector has direction and magnitude.
Yeah, actually, I want to improve this little bit. Actually, you have said right, but little bit you have done mistake. I am saying that scalar quantities have only magnitude. Scalar quantities have only magnitude, and uh, vector quantities have direction as well as magnitude.
Magnitude.
Like a scalar quantity, you can say charge. Charge is a scalar quantity. There is no direction for charge. When the charge will be in direction, it will become current. Means
Yeah.
okay. So I remember that like speed is a scalar quantity, charge is a scalar quantity, distance is a scalar quantity. These quantities are the scalar quantities. Okay. And accordingly, we can say force is a vector quantity because force have direction and magnitude. So what about the current? Now I will explain you what type of quantity the current is. We have two types of quantities, scalar and vectors. Scalars have only magnitude and vectors have magnitude as well as direction. So current, uh, like I am saying, I have represented current with I. I is current now, and current have, you have seen here, you see here, I I can say na this charge is flowing in this direction, so means the current is flowing in this direction.
Yeah.
Current is flowing in this direction means there is a direction of current. I can say like this. I can say like this. This is the wire. This is the wire, and current can flow in this direction also. This is the current, and current can flow in this direction also. So means current have a direction. Current have a direction. And also, I can say a 5 ampere current is flowing, a 4 ampere current is flowing. So I can say the current have the magnitude also. Current have magnitude also. So those quantities which have direction as well as magnitude are vector.
Yeah,
So current is a
vector quantity.
not a vector quantity. Current have direction. Current have direction plus magnitude, but it is not the vector quantity and not the scalar quantities. See, I will tell you how this is happening. For a quantity to be a vector, it must have magnitude, direction, as well as it must follow the uh, laws of vector addition. It must follow the laws of vector addition, but current does not follow the laws of vector addition. See,
Okay.
see this. Uh, Please listen carefully. This is very critical point. Uh, Here is a force F1, and here is a. If you have little bit idea of vector, then I am telling you. There are two forces at an angle theta, and force is a vector. We know that. Force is a vector. We know that. So
Yes.
force have magnitude, force have direction, and this force will always follow the law of vector addition. Like if I want to find the resultant, law of vector addition means law of vector addition is simply the resultant of two vectors. The formula for resultant is f1 square, no, f1 square plus f2 square plus 2f1 f2, 2f1 f2 and cos theta. Means the magnitude of this force, r is the magnitude, sorry, r is the resultant of this force, means you can say this is net force. Net force, these are two vector quantities, and the net force is depending upon theta, is depending upon theta. And when you change this theta, like this f1 is like this and this force is like this, and the angle becomes 90 degree, then this will become 0, means the resultant will change this time. Now resultant will change. Here will this will become f1 square, this will become f2 square. Now here, see here, net force has changed when you have changed the angle. Now see what happened when we change the angle for current. Suppose a current of 2 ampere is flowing like this, and a current of 3 ampere is flowing like this, and the angle between the direction of current is 60 degree. And here what is the value of current? Here is what is the value of current? We know we will add these currents simply. We know
Yes.
that we will add the current simply. This will be 5 ampere. Now I am changing the angle. This is the net current. This is the net current. Now I am changing the angle. What I am doing, 2 ampere current is flowing like this, and 3 ampere current is flowing like this, and now the angle is 90 degree. But again, the net current here is 5 ampere. Means there is no effect of angle. There is no effect of angle. Here, if this current follows the law of vector addition, means it will change with the angle, but the current is not changing with the angle. So we can say current is not a vector quantity. Current is not a scalar quantity. Current is a tensor quantity. Current is a
Okay.
tensor quantity, and tensor quantities are not in your syllabus. So you will consider current. You will add current like the scalar quantities. Like you can add the current like 5 ampere plus 2 ampere equal to 7 ampere. You will
Yes.
not use the vector laws here. We add the vectors with some laws. We have this formula. If you have remembered, then no problem. If you have not remembered this, then no problem. But we know that vectors, for the addition of vector, there are certain laws. In 11th class, there is whole chapter on the vector.
Yeah, we had one chapter.
Yeah. Okay, no problem. If you have forgotten, then no problem. But I am just telling you. So basically, the my motive is to tell you, current have direction, current have magnitude, but current is not a vector quantity. Current is not a vector quantity, and the current is a tensor quantity. Current is tensor quantity. But you should consider, because tensor quantities are not the part of your syllabus, so you will consider current. I am saying just consider current as a scalar.
Scalar.
Consider current as scalar. What is the meaning of that? Meaning of this is you will add the current simply like scalars. 5 plus 2 is equal to 7 and all that.
Okay.
Okay. And if you are not getting any point, please you can tell me.
Yes.
I will explain that again.
Sure.
So that's all. So basically, see, this is the introduction. So basically, you have studied about the current. So current is just charge divided by time. Simply, if you will say, then you will say charge flowing, or you can say charge divided by time. And there are two. We will calculate the current as average current. Average current is total charge flowing divided by time. Okay, total charge flowing through the cross section area divided by time taken. I have given you one example also. And after that, we have calculated the instantaneous current. For the instantaneous current, I have used this D. I will tell you why I have used this D. D is for dq and dt is very small amount of charge. That's why I have written D. And we have the differentiation. We have differentiation. Do you know about the what is? Do you know about differentiation? Do you
Uh,
have any idea? Little bit, no problem. If no, you can tell me.
I'm not sure, sir.
Okay, no problem. So you are a medical student or
Yes,
math
sir.
student?
No, biomedical student.
Yeah, that's why now. Because in the syllabus of the students of PCM, that physics, chemistry, math, they have the chapter differentiation in the 12th class.
Oh,
That's why they know about the differentiation. But you should have the basic idea of differentiation, because for solving the instantaneous current, the question based on instantaneous current, we will need the differentiation. Simple differentiation we will need. We will know, not going in depth. So this is the topic now, and I am giving the brief idea about the differentiation. So differentiation is, see here, suppose y is equal to x square. This is x square, and I am saying that differentiate y with respect to x. Differentiate y with respect to x. So you will write dy by dx. This is the differentiation of y with respect to x. Differentiation of y with respect to x. And if you want to calculate the differentiation of this y, and y is equal to x square, then you will write here this 2. First here you will write this 2, and you will write 2 minus 1. In the power, you will minus 1. Like to show the value of this 2, x to the power 1. Na?
yes.
See here, this is x, This is square and I minus power 1. What will it become? X to the power 1 and x to the power 1 is 1. X.
Yeah. Yeah.
Now, if I am saying for y is equal to x cube, so write this power 3 here first. And right here, instead of x cube, write x square. Okay. Suppose y is equal to x to the power 4 and I want to find dy by dx, means differentiation of y with respect to x. Then how should I write it? I will write 4 first here.
Yeah.
And here is I will decrease one power of x to the power 4. When you decrease power
3
from this x cube, this will become x cube.
x cube.
Earlier is what it was x4, now it is x3. Simple. And
Yes.
if you are doing y is equal to x to the power 6 and you want to calculate dy by dx, first you will write this 6 here, and here what will you write? X5.
Yes.
So I am giving you one. I'm just want to know whether have you understood or not. So please tell me the answer is y is equal to x to the power 8 and I want to find dy by dx.
So it's 8, then
Yeah,
x to the power 7.
very good. Very good. Very good. I am saying x to the power 101. Then please dy by dx. This is y is equal to. Now, please tell me what is the answer.
101 x to the power 100.
Very good. Very good. This thing you should know only.
Yes.
I am just changing little bit. If the if y is equal to 5x square, so in that case, if you want to differentiate y with respect to x, means differentiate y with respect to x, then you will what you will do, you will multiply this number with this. Multiply this number with this. This will become 10 and decrease one power of x. So if y is equal to 10 x to the power 4, if you want to calculate dy by dx, then you will multiply this with 10. This will become 40 and decrease one power. This is x power 4. This will become x power 3.
Cube.
And I am saying that this is 100 x power 5 and I want to calculate dy by dx. Can you tell me the answer?
500 x
Yeah.
4
This is 5.
to the
This
power.
will become 4. Fine. Means
Yes,
now
sir.
you are getting my points, I think. So
So
suppose if
use this in numerical solving and all?
what?
Like, do we use this differentiation thing in numerical solving?
Of course, in the next in the very next question, I will use this. That's why I am telling you.
Okay, because like when in our chapter, our teacher didn't teach this part, so
But
it's
in the board examination, this part will appear, na?
okay.
Your teacher is teaching or not teaching. That is the different thing. But
Yeah.
the examiner will ask you. Then what will you do? You can. Okay. I don't know why your teacher don't tell you the differentiation, because without the use of the differentiation, you cannot learn the physics.
Okay.
You should know only this small type of differentiation. Differentiation is very lengthy chapter in 12th class. This is just the 0.1% of differentiation. 0.1% only. It's very basic and simple. Because the questions is coming in your examination. I am not saying by myself.
Yes, sir. I understand.
Yeah, yeah. So if I am saying, like I have written here is, instead of y, now I am written as q, and this q is written in terms of t, 3t square plus 5t plus 6. So do one thing before that. If y is equal to 3x cube plus 5x square plus 6, and remember that if you will differentiate this constant, this is constant, if you will differentiate this constant, any constant, then differentiation of that is equal to 0. Y is equal to, if constant, then dy by dx is equal to 0. So now I want to differentiate this function this time. I want to differentiate this function. So what we will do for this? Tell me now.
We'll multiply 3 into 3, so 9x raised to 2.
And for this?
10x.
And for this?
And then 0.
Very good. If I am replacing now y with q. Q is charge, and this will become 3t to the power 5 plus 5t square plus 9. And this is charge, q is charge this time. Earlier, y is some variable, y is some dependent variable, x is independent variable. Now this time this is the charge, and t is the time. T is the time. So if I want to calculate dq by dt, similarly like dy by dx, so what will you do here? This will become 15.
Yeah.
T to the power 4.
Yeah.
This will become 5 to the 10. And this will become 0. Okay, now my work has done, and we have one question. If charge q is the charge, remember that q is the charge. If charge is given like t square plus 4t plus 5, 4t plus 5, we have to calculate number one, instantaneous current, I instantaneous current at t is equal to 2 seconds. Second part is average current, we have to calculate from 0 second to 2 seconds. These kinds of question you will get in your board examination. And I want to calculate I instantaneous. So the first part, and I instantaneous is differentiation of q with respect to t, dq by dt. See here, dq by dt,
Yes.
instantaneous current. Now there is a use of differentiation. That's why I was telling you. That's why. Now what you will do for this t square? When you differentiate this t square, what you will do? In the same way you have to differentiate, na? Like here you have differentiated. Earlier you have differentiated x cube. What you have done? You have write 3 first, and after that
Yes.
decrease 1 power. Here you, what you will do?
2t.
Very good. And this will become 4. 4.
Yeah, and 0. Proceed.
0. I am not writing 0.
Okay.
And now put t equal to, they are asking at t equal to 2 seconds. Now put t is equal to 2 here. This will become 8 ampere. So now see,
Yes.
that's why I was, okay, have you understood why I was teaching this?
Yes, sir. Yeah.
Okay, fine. Second part is we have to calculate the average current. And for the average current, I am telling you delta Q by delta T. So you can say delta Q means charge final minus charge initial divided by final time finally minus time initially. So charge final is, this is the time, initial time. They are asking from 0 to 2 seconds. So this is T initial, time initial. This is the final time finally.
Yes.
So we will calculate charge at t is equal to 0 and we will calculate the charge at t is equal to 2. So this is the charge at t is equal to 2. This is the charge at t is equal to 0. And initial final time is 2 seconds and initial time is 1 second. Sorry, 0 second. Final time is,
0 seconds.
this is initial time. This is final, this is initial. Final time is 2 seconds, initial time is 0 second, and charge at final time t is equal to 2. So we have q t square plus 4t plus 5. T square plus 4t plus 5. And I want q at t is equal to 2. So put the value of 2 here instead of t. 4 into
2 plus
this will
5.
become 17. This will become 17 coulomb. Okay.
Yes.
And if I want to calculate t is equal to 0, so I will put, instead of t I will put 0. This will
Yeah.
become 4 into 0. This will become 5. 0. This is 0. This is 0. This is only
5.
5. So if I want to calculate the I average, so I will write q at t is equal to 2. Q at t is equal to 2 is 17. And this is 5. Q at t equal to 0 is 5. And t final is 2, 2 minus, this is 2 minus 0.
2.
2. This will become 2. So what is the answer of this?
6
Very good.
ampere.
6. One more question we will solve on this. One more question we will solve on this. Charge, q is the charge. Charge is changing with time. Like here the charge is changing with time. Remember, t is the time here. T is time here. Charge can change with respect to time. So the equation of charge is given here. So q is equal to, if q is given as 3t square, you have to do the same thing again and again. 3t square plus 2t plus 1. And you have to find instantaneous current. You have to find I instantaneous at t is equal to 1 second, and you have to find I average from t equal to 0 second to t equal to 2 seconds. This you have to find. For the I instantaneous, I will write dq by dt, and I will differentiate this again. I will differentiate this. So what we will do here?
60 plus
60 plus 2.
plus 2 plus 0.
Yeah, plus 0.
That's
And now put the value, they are asking at t equal to 1, put the value of t1 here.
so it'll be 6.
This will become 8 ampere. Now this is so simple for you. If you want to calculate I average, so what you will do? You will write delta q by delta t. Now you will write q final minus q initial, charge final minus charge initial divided by time final minus time initial. And charge, what is the value of charge final? Means you have to find charge at this time. Charge at this time means you have to put the value of t here.
Yeah.
2 here. So when you will put the value 2 here, this is q at t is equal to 2 minus, this is q at t is equal to 0. This is 2 minus 0. So now can you solve this? You will put the value 2 in the here, 3t square plus 2 into 2 plus 1, and this will become minus 1, and this will become 2, and you will get the answer 8 ampere. No, sorry. This will become what I have done here. Okay, no, not the 8 ampere. Just changing now. We have to find q at t is equal to 2. So what we will do? We have the equation 3t square plus 2t plus 1. 3t square plus 2t plus 1. We will put the value of t as 2. We will put the value of t as 2, and this will become 2 into 2. Instead of t, I have written 2. This will become 1. This will become 17.
17, yeah.
This will become 17 coulomb. And if I want to find charge at t is equal to 1, then I will put value of t as 0. Oh, sorry, not 1.
1.
This is for 0. I will put the value 0. 0 square plus this will become 2 into 0. This will become 1, and charge at t is equal to 0 is 1 coulomb. Now I average is equal to q at t is equal to 2. Q at t is equal to 2 is 17.
17 coulomb.
Q at t is equal to 0, 1, and this is 2. What is the value? This will become 16 divided by 2. You will get the 8 ampere. You will get the 8 ampere. So in this way, you can now solve these kinds of questions. I'm just giving one more question. Not like this, but this question is something different. An electron revolves around the nucleus with frequency f. With frequency f, calculate the current. So they are saying here is an like this. This is the nucleus. We know that at the center, nucleus is the center of atom.
Yes.
I am supposing this is nucleus and this is nucleus, and an electron is revolving around the nucleus, and we know electrons revolve around the nucleus in the circular orbits. So here is the electron, you can see, and this electron is revolving around the nucleus. Like here is some person, electron, you can imagine this like that person is around revolving around that nucleus. Okay,
Yes, sir.
so see here, this is electron, and we know that electron have the charge. Electron have charge. Electron is a charge particle. And what is happening here? I have told you that whenever the charge particle will be in motion, there will be the current. So here the electron is revolving around the nucleus. Means electron is in motion. Electron is moving. So the current will produce. Okay, so the
Yes.
current will produce, and we know that there is a charge on electron. Charge on electron is charge on electron is 1.6 into 10 to the power minus 19.
Yes.
10 to the power minus 19 charge on electron. Coulomb. So I am representing charge on electron. Charge on electron is equal to minus E. I am taking this value as minus E. No problem, na? We can take. There is no problem. I am just writing like charge on electron is minus E.
Minus.
Charge on electron is minus E. This is I am representing it, and this is minus sign. Charge on electron is negative. Charge on electron is this. And one thing more you have to know here. There is a term frequency here. Frequency and time period are related as frequency is equal to 1 upon time period. T is the time period. And now what is time period? Time period is the time taken by the electron to complete this circle. Means electron started from this point, and after moving like this, like this, like this, like this, like this, and electron again at this point. And this time is known as time period, and time period is related with frequency is 1 upon t. So we know that we want to find the value of current, and current is charge upon time, charge flown divided by time interval. I have told you in the beginning. So what is the charge on charge flowing? What is the charge flowing? This charge is flowing, minus E charge is flowing,
Yes, sir.
minus E charge is flowing, this is minus E charge, and then minus E charge is flowing. Minus E charge is flowing, and in what time it is flowing? Time period means from electron is moving from here to here to here to here to again the electron is here. So we have time as time period T. Okay.
Yes, sir.
And we I can write 1 upon T as F.
Yeah.
I can write this like this. So I can write this
Minus
E
into
comma F. I can write this minus EF. So we have the answer minus E into F. F is the frequency, and time period is time taken to complete one rotation. One rotation of means if you are starting from here and again you are here, and in that time, that time is known as time period. So see here, one thing I want to discuss here. Just I am taking 5 or 4 minutes more, and I want to discuss here. See here, electron is moving in this direction, and here is the negative sign. Here is the negative sign. So if the motion of electron is in this direction, the direction of current will be in this direction. So now write the heading. There is another topic is direction. What is the direction of current? What is the direction of current? This is the last topic of this class. Are you there?
Yes, sir. Let's check.
Okay, no problem.
Yes, sir.
Okay, fine. So direction of current simply is if a positive charge, if a positive charge is moving in this direction, then the direction of current will also be in this direction. Direction of current will be in this direction. If a negative charge is moving in this direction, then the direction of current will be opposite to the motion of charge. So I am writing here so you can say the direction of current is same as the direction of motion of positive charge. Motion of positive charge. Or you can say it is opposite to the direction of motion of negative charge. See here, electron is a negatively charged and electron is moving in this direction. Electron is moving anti-clockwise direction, but the current here in this direction. Okay. If the electron moves like this, you can, for example, if there is an electron is moving in this direction, then the direction of current will be the opposite direction of motion of electron. Okay. If a
Yes,
positive if a positive charge is moving in this direction, then the direction of current is the direction of motion of positive charge. Means it is opposite to that motion of negative charged particle, or you can say same as that of positive charge. So this was all about this is a basic idea of the chapter. This is an introduction of the chapter. And if you have any doubt, you can ask me. Do you have any doubt?
no, sir. I understood.
You understood? Okay, very good.
Yes.
So basically, electric current, you have to calculate in the questions average current and instantaneous current, and I have already told you the differentiation. You should know only this type of differentiation. This is simple. So you are able to do these kinds of questions only.
Yes, sir.
And these questions will appear in your examination. And these kinds of questions, and after that we have discussed the direction of current. So direction of current is, please tell me what is the direction of current?
Sir, it is same as the motion of positive charge.
Yeah, and opposite to the motion of